insertion and deletion operation takes place at two different points or two different ends. That is the definition of queue. Whoever comes in the queue first, he will be the first one to leave the queue or going out of the queue. That is the concept of first in, first out. Where is the pointer where insertion takes place? Now we want to insert one more element into a queue. We have to increment the rear pointer by +1. Dear students, welcome to CS classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, today let us start our session with the topics arithmetic expression and queue. Now let us see what is arithmetic expression. Arithmetic expression is a combination of operands and operators that after the evaluation results in a single value. Operands consist of constants and variables. Operator consists of plus, minus, star, etc. Now, if I come across in C++ what are arithmetic expression? It is a combination of operators plus operands. For example, suppose if I write here A plus B. In this example, A is a variable, B is a variable, plus A is an operator. So here, this is an operator. It is an operator, and on either side of operator are called operands. O-P-E-R-A-N-D-S, operands. So here, arithmetic expression is a combination of variables plus operators. So here, this operand, in this example, A and B are operands or variables, and operands, it may be a constant also. For example, suppose if I write here A plus 10. In this example, plus is an operator and A is a variable and 10 is a constant. So this is an arithmetic expression. So operands can be constants or variables, and operators, or it can be any of the operations or operators, plus, minus, star and slash, that is for division. So this is the definition of arithmetic expression. It is a combination of operators and operands, and on either side of operators are called operands. In this example, A, B, A and 10 are called operands. Now let us see the different types of arithmetic expressions. Now, expressions can be infix expression, postfix expression and prefix expression. Now let us see the difference between these three. Now let us see the definition of infix expression. If an operator is in between the two operands, it is called as infix expression. So here, operator is between two operands. Same thing what you have seen in the previous slide. It is A plus B. In this example, plus is an operator and we have operands on either side of operator. So this is infix expression. So this is infix expression. Same example, you can say A plus B. Here, plus is an operator, A and B are operands. Now let us see another type of expression, postfix expression. If an operator follows the two operands, it is called postfix expression. Please understand now, an operator follows the operands. In this example, look at this now. This is infix, A plus B. Now consider this example here. In this example, A and B are operands and is followed by an operator. It is called postfix expression. Here, operator follows the two operands is called postfix expression. Now let us see another example, prefix expression. If an operator precedes two operands, it is called prefix expression. So here, look at this example here. Here, A and B are operands and plus is an operator. It precedes two operands, means before that operands we have an operator. So this is prefix expression, and here operands, then we have operator, it is postfix, and between two operands we have operator, it is called infix expression. Now let us take an example of A plus B minus C. In this example, A plus B minus C. So this is infix. Now how can we convert this into prefix expression? In this example, consider these two expressions now. So this is A plus B. So this can be A, B and preceded by an operator, that is plus operator. So then minus C will be as it is in the first step. In the next step, consider these two, then it becomes this operator comes to this position. So it can be, so we can write it as minus B, A, B and C. This is the infix expression for the given function A plus B minus C. So this is, we have converted the given infix expression into prefix expression. Definition is, here the operands precedes the operator. That's the definition of this. Now let us look into one more example here. A plus B star C plus D. In this example, if you consider A plus B first, so if you say A plus B first, so plus AB will be the result of this. Then after that, star will be as it is and C plus D. So it becomes plus CD. Okay, in between we have a star. So star come to this point after this. So this is your prefix expression for the given infix expression. Similarly, you can see the another three examples, or it is nothing but conversion from infix expression to prefix expression. Now let us move on to next slide. It is queues. Now let us discuss about a queue. It is a data structure. In our previous session, we have learned about stack. It is a data structure. Now queue is one more data structure. So let us see the definition of this. Here, a queue is an ordered collection of items where the addition of new item and removal of existing item always takes place at two different ends. So queue is a data structure where the elements are arranged in definite order with a continuous index. So in this example, so what is the definition here? Queue is a data structure. Here, addition of new item, nothing but insertion, and removal of existing item, that is deletion. Insertion and deletion operation takes place at two different points or two different ends. That is the definition of queue. Now, a queue is an ordered collection of items where an item is inserted at one end called rear end here. This is the rear, and an existing item is removed at the other end called the front. So queue maintains a FIFO ordering principle or property. Next point is, a queue is also called as FIFO list, that is first in, first out. FIFO stands for first in, first out. Here insertion are limited to one end of the list called a rear end, whereas deletion are limited to other end called as front end. That's what I have seen in the previous point. Example, student in a queue for a fee payment or people queue in a ticket counter. This is a simple example where you can simulate the queue. Whenever you are standing in a queue, maybe at the counter, so that is you are the one, who is the person very near to the counter, he will get the ticket first. Then second next person, the person who behind him, he will get the chance to buy one more ticket. So that is what. In a queue, the first person entering a queue, he is the one to leave the queue. That is the concept of FIFO, first in, first out. So in a counter, whoever comes first in a queue, he will get the ticket. So then after purchasing a ticket, after getting a ticket, he will be coming out of the queue. That means the first in, first out. Whoever comes in the queue first, he will be the first one to leave the queue or going out of the queue. That is the concept of first in, first out. This is an example for queue. Now let us see the different types of queue that can be simple queue, circular queue, priority queue, and DQ. DQ stands for double-ended queue. Here, these are all different types of queue. Now let us see the definition of all these one by one. Now let us see what is a simple queue. In a simple queue, insertion occurs at rear end of the list and deletion occurs at the front end of the list. So here, for example, look at the example now. This is an example of a queue. It is, we are implementing queue through array. So this is an array. Here array index start with 0, 1, 2, 3, 4, 5, 6, 7, 8. So index says, last index is 8. The size of an array or size of a queue is 9, or here we can insert 9 data items. And as what you have learned in our previous definition of queue, there are 2 points. One is front and one is rear point. So rear is the point where insertion takes place. So here at the beginning, see, suppose in this example there are 5 items. Suppose in the beginning, so if there are no data items in the queue, it is the queue is empty. In that condition, the rear as well as point, the rear as well as front, these two the pointer points at the -1, or in this example 0. In this example, the index is 0. First element we are inserting at A. First element is A. So at the index 1. So at the beginning, there are 2 pointers, front and rear. There are 2 pointers, both of them will point to 0. 0 in the sense, in this example, 0 means there are no elements. Now, if you want to insert one element into queue, here rear is a pointer where you have to insert or insertion takes place. So we have to push the pointer, rear pointer from here to here. So here rear pointer will be here at the beginning. So we have to push this pointer to this point or at the index equals to 1. So once the rear is the pointer at the index 1, so that is the place where we can insert one data item into queue. Similarly, so in this example, A is inserted. Similarly, if you want to insert one more element, here we have to push this rear pointer to index 2. So there we can insert second element. Similarly, if we keep on incrementing the value of the rear pointer by +1, there we can insert new data item into the list or into the stack. In this example, rear is point the index 5. So this is the place we have inserted the element data item E. When this process is going on, front will be in the index 0. In this example, please understand now, in this example, at the beginning, both of them are point to 0, means it is a empty queue. After inserting few elements into a queue, now look at the position of the rear and front pointer. So rear pointer in this example at this stage, value of rear equals to 5. Now at this stage, value of the front pointer is pointing to index 1. So this is the where is the pointer where insertion takes place. Now we want to insert one more element into a queue. We have to increment the rear pointer by +1. Now that is one point. Second point is deletion occurs at the front end of the list. So deletion occurs at the front end. Now look at the front end. The front end is point to the index 1, data item is A. So this is the place pointer where deletion takes place. So if you want to delete any element from the queue, this is the first element to be deleted. That is the meaning of first in, first out, because we have inserted the first element A, next element B, C, D, E, and so on. As per the definition, A is the element to be removed or deleted from the queue. This is the concept of F5, F4, first in and first out. So this is an example for a simple queue. Now let us look into another type of queue, that is circular queue. What is circular queue? It is a queue in which all the nodes are treated as a circular such that the last node follows the first node. Here, in this example, this is the last element. It is pointing to next element. So that is the place. But in this example, here observe this, as per the definition, the last node follows the first node. The meaning is, in this example, rear is the pointer, and for insertion, so first 0 index 0, 1, 2, 3, 4, 5, 7, 8, and after 8, the last node or the C, it is pointing to the first index, that is 0. So this is in a circular fashion. That is why it is called as circular queue. The definition is that the last node or last data item is pointing to the first or at the beginning 0 index. This is called a circular queue, another type of queue. Next we move on to another queue, that is priority queue. Here definition is, a priority queue is a queue that contains items that have some preset priority. An element can be inserted or removed from any position depending on some priority. It is another type of a queue where the insertion and deletion can take place on some preset priority. So this is an example here. These are the priorities in the example, and 30 and 40 is the highest priority. Here 30 and 40 are highest priority, and 11, 22, 33. 11, 22, 33 will be next priority, and 99 is the least priority. So accordingly, the elements can be inserted or deleted based on the preset priority. It is a priority queue. Now let us move on to next slide. Here this is DQ. DQ stands for double-ended queue. Here it is a queue in which insertion and deletion takes place at both the ends. Now look at the example here. For example, this is an array where we are implementing array on queue. So this is an array or this is a queue with so many data items, and here the pointer insertion and deletion are pointing at the both the end of the queue. So this is at the beginning and this is at the end. So this is the beginning of the first index 0, 1, 2, 3, 4, 5, 6. So if you look at this type of queue here this is a place where we can insertion and deletion can be done, or insertion and deletion can take place at this end. It is also possible, and also insertion and deletion can be done at the other side of queue, in this example at the index 6. So that is the meaning of double-ended queue, where insertion and deletion can take place at both the ends of a queue. Students, let us continue our discussion in our next session. Thank you very much.